Welcome back to JVM Internals Crashcasts. I'm your host Sheila, and today we're continuing our journey through the core concepts of the Java virtual machine. We're in the first season JVM Novice, and we're exploring the fascinating world of runtime data areas. Victor, our JVM expert, is here to help us unravel this complex topic. Are you ready to dive in, Victor?
Absolutely, Sheila. I'm excited to explore runtime data areas with our listeners. It's a crucial part of understanding how the JVM manages memory and executes Java programs.
Great. Before we start, let's remind our listeners that we've already covered the introduction to the JVM, including what it is, how it differs from the JRE and JDK, and a basic architecture overview. Today's topic builds on that foundation. Now, to kick things off, I have a quiz question for our listeners. What do you think, Victor? Should we challenge them right away?
That sounds like a fantastic idea, Sheila. A quiz question is a great way to get our listeners thinking about the topic. Go ahead and hit them with your best shot.
All right, listeners, here's your quiz question for today. In a Java program, where are local variables stored during method execution? Is it A, the heap, B, the stack, C, the method area, or D, the program counter register? Take a moment to think about it, and we'll reveal the answer at the end of the episode.
That's an excellent question, Sheila. It really gets to the heart of how the JVM organizes different types of data. Without giving away the answer, I think this question will help our listeners understand the importance of distinguishing between different runtime data areas. Each area has a specific purpose, and knowing where different data is stored is crucial for understanding JVM memory management.
You're right, Victor. Now, before we dive deeper, could you give us a basic definition of runtime data areas? What are they, and why are they important?
Certainly, Sheila. Runtime data areas are memory regions that the JVM uses to store various types of data during program execution. They're essential because they provide the structure for organizing and managing memory in a Java application. Think of them as different compartments in a kitchen, each designed for a specific purpose.
That's an interesting analogy, Victor. Could you elaborate on that? How are runtime data areas like kitchen compartments?
Sure thing. Imagine a kitchen where you have a pantry for storing dry goods, like the heap for objects, a counter for food preparation, like the stack for method execution, a recipe book shelf, like the method area for class information, and a timer, like the program counter register for keeping track of the current instruction. Each area has a specific purpose, just like our runtime data areas.
That's really helpful, Victor. Now, could you give us an overview of the different runtime data areas?
Absolutely. The main runtime data areas in the JVM are 1. The heap, where objects are allocated. 2. The stack, for method execution and local variables. 3. The method area, storing class structures and static variables. 4. The program counter, PC. Register, tracking the current instruction. 5. Native method stacks, for executing native methods. Each of these areas plays a crucial role in how Java programs run.
That's quite a list. Let's start with the heap. What exactly is stored there, and how does it work?
The heap is where all objects in Java are allocated. When you create a new object using the new keyword, it goes on the heap. This area is shared among all threads in the application and is managed by the garbage collector. It's like the pantry in our kitchen analogy, a place where you store items, objects, that can be accessed by anyone in the house, different parts of the program.
I see. And what about the stack? How does it differ from the heap?
Great question. The stack is quite different from the heap. Each thread in a Java application has its own stack, which is used for method execution. When a method is called, a new frame is pushed onto the stack. This frame contains local variables and partial results. When the method completes, its frame is popped off the stack. It's like our kitchen counter, a workspace for active tasks that gets cleared when the task is done.
That makes sense. Now, I've heard that understanding the difference between stack and heap is crucial. Why is that?
You're absolutely right, Sheila. The stack-heap distinction is fundamental to understanding Java memory management. Objects on the heap persist beyond method calls and can be accessed from different parts of the program, while variables on the stack are temporary and tied to specific method executions. This impacts things like variable scope, object lifetime, and memory usage patterns. Misunderstanding this can lead to common pitfalls, like memory leaks or inefficient memory usage.
Interesting. Could you give us an example of how this might affect real-world application performance?
Certainly. Let's say you're developing a web application that processes user requests. If you mistakenly create large objects for each request and store them on the heap, instead of using stack-based local variables where possible, you might end up with excessive memory usage and frequent garbage collection cycles, slowing down your application. Understanding runtime data areas helps you make better decisions about data storage and improve performance.
That's a great example, Victor. Now we've covered the heap and stack in detail. Could you briefly explain the other areas, the method area, PC register, and native method stacks?
Of course, the method area, also known as the perm-gen space in older JVM versions, stores class structures, method and constructor code, and static variables. The PC, program counter, register contains the address of the JVM instruction currently being executed, and each thread has its own PC register. Native method stacks are similar to regular Java stacks, but are used for executing native methods written in languages like C or C++.
Thank you, Victor. As we wrap up, could you share a common misconception about runtime data areas that our listeners should be aware of?
One common misconception is that the JVM's memory areas are fixed in size. In reality, many of these areas can grow or shrink dynamically based on the application's needs and JVM settings. Understanding this can be crucial for effective JVM tuning and optimization.
That's a valuable insight, Victor. Now it's time to reveal the answer to our quiz question. The correct answer is B, the stack. Local variables are stored in the stack frame of the method being executed. Victor, any final thoughts on why this is important to remember?
Absolutely, Sheila. Remembering that local variables are stored on the stack helps us understand their life cycle. They're created when a method is called and destroyed when it returns, which is different from objects on the heap. This knowledge is crucial for writing efficient and memory-conscious Java code.
Thank you, Victor. To summarize today's episode, 1. Runtime data areas are memory regions used by the JVM to store different types of data. 2. The main areas are the heap, stack, method area, PC register, and native method stacks. 3. Understanding the differences between these areas, especially stack versus heap, is crucial for effective Java programming. 4. These areas play a significant role in application performance and memory management. In our next episode, we'll be diving into the execution engine of the JVM. Don't miss it. If you've enjoyed this episode, please subscribe to JVM Internals Crashcasts and leave us a rating. Your support helps us continue creating valuable content. Until next time, happy coding.